Hello, everybody. So my name is John Stevens. I work for AbbVie. So if you haven't heard of AbbVie, we are a pharmaceutical company, actually soon to be the fourth largest pharma company in the world once our acquisition of Allergan goes through. So what I do, I work on the AI team at AbbVie. We call ourselves the Raiders, and we're a pretty small, plucky group within a very large company. So I feel like I kind of work for like a little startup, even though we have like 40,000 employees. So what I do mostly is work with natural language processing, NLP, text analytics. My background's in computational linguistics, and I've been lucky to be working with Jim and with Smartlogic on some really interesting literature classification problems. So I'll hand it over to Jim.
Yeah, my name's Jim Morris. I'm an information scientist and solution architect at Smartlogic. And before joining Smartlogic about 5 years ago, I worked in pharma. I was an information scientist, librarian, information architect. I called myself whatever worked at the time. And spent most of my career in that world. And when I joined Smartlogic, it was really cool because then I get to work with all kinds of pharmaceutical and other life sciences companies and work on lots of different projects and meet people like John and his team that are doing brilliant things with technology like Smartlogic. So if you guys were here earlier, you probably saw Jeremy's presentation. So there's a lot of orientation to Semaphore. I don't want to repeat too much of that, but just to summarize, if you weren't there, Semaphore is a semantic platform, a semantic AI platform, and it's all about enriching, extracting, harmonizing your information, your data. Your data is usually not in a format that makes it useful, and of course that's the whole point of this conference. It's about analyzing this data that's challenging to use and turn it into valuable, high-quality data that actually solves problems. And so, as John said, they're using Semaphore to do some really cool things at AbbVie, and he got in touch with me and said that there was this one issue that he was dealing with, and I'll let him explain that. And I said, that sounds like an opportunity, John, an opportunity to present at Text Analytics Forum in November. So why don't we work on it together and summarize our findings for this conference. With that, I'll let John describe more about the challenge. Oh, one more thing. Jeremy showed this as well, just to kind of put us in the context of AI in general. You know, Semaphore is very much focused around the top of this slide, where we have an NLP engine that's machine learning built, but we also have ontological models that work with those NLP engines that deliver value, and we'll get into more details about that later. So John's got the details.
Right, yeah, so I'll just start with a word about what my team is doing with Semaphore. So I work with the AI team, as I said, and also with the AbbVie library, and we have been building these custom literature portals for our customers, for our clients within AbbVie. So we have lots of different research groups. For example, this is oncology, where we build a website custom for that research group where they can select from drop-downs. They can search and filter by the types of cancers, the types of cancer drugs, and a bunch of other general topics, right? So that they can get the literature, the scientific literature that's relevant to them without having to go construct complicated PubMed search queries every time they want to find something, right? And so we've done this for a number of groups, oncology, HIV, and others. And we've stumbled many times over the phrase oncology ontology because we use ontologies to do this, right? So we need ontologies to encode the knowledge, for example, that lung cancer, lung carcinoma, carcinoma of the lung all refer to the same thing, right? The same concept, what we would commonly call lung cancer, right? And so the ontologies are necessary, but they are not quite sufficient, right? So if you go on the next slide, we have an example here where we actually require some natural language processing, some NLP, to extend what the ontologies can do. And this is one of the nice aspects of Semaphore, because it also can handle some of this NLP heavy lifting as well, right? So here we have just a very simple example of a plural noun, something like biomarkers, right? And thanks. And so something like biomarkers is an important concept for us, right? But we ran into a problem right away where it wasn't really a problem, but we noticed, oh, hey, our ontology only has the word biomarker, right? And of course, you don't want to have to add biomarker and biomarkers. You don't want to have to add the plural of the noun every time you put a new concept into your ontology, right? This is obvious because these are not two different words, right? These are two variants of the same lemma, as we would say in linguistics, right? A lemma being kind of a single word object, right? So this is sort of a very simple example, but it just shows that, this is a fact about the English language, right? That you can slap an S on something and that it becomes a different form of the same word. It's not a fact about the concept of biomarkers, right? It's not something that we sort of deeply care about from a content perspective, right? A somewhat more complex example of why we need NLP, right? So NLP can tell us, yes, these are both the same lemma, and that's great. We also can look at things like part of speech and other aspects of the sort of linguistic analysis of these words, right? So we have some kind of contextual rules that we can implement within Semaphore. Like if we're looking for a concept like back pain, right? We might have set up a rule that basically says if we have, back or some synonym of back within so many words of pain or whatever it is, that we can tag our literature, that article with that concept of this is about back pain, right? But we tried to do this and we very quickly realized that the way we were implementing it was a little bit naive because we had instances like Back to the Future of pain management, right? Where clearly this does not refer to back pain, right? So we're like, okay, what do we do, right? So this is a case where having some part of speech information actually would be useful, right? I mean, it won't get us 100% of the way there, but it's useful to know here back is an adverb. We don't care if back's an adverb, we don't care about it, right? Because it's never going to refer to the back, right? Similarly with the verb, right? So back is like a very kind of ambiguous word in the language, right? So what we actually have are kind of two possibilities to kind of lemmatize these words, right? So kind of the old school way, what we might just call stemming, right, is a kind of a rule-based, this is on the left, a rule-based lemmatizer which basically has some rules that basically say, oh, this is backs, and we could chop off an S and it becomes back, and then you're done, right? And what we actually have in Semaphore is this kind of off-the-shelf statistical model, right, that basically can take all these other aspects into account, can take the context into account, and can also make inferences about the part of speech and include the part of speech in the lemma, right? So now we have a context like when the patient backs out of a clinical trial, this is just a hypothetical example, if it can infer that this is a verb, yes, it might stem it down to the word back, but it's the verb back, right? And so having that information encoded is something that can be really important to disambiguating these highly ambiguous words. And this statistical approach, I think, is generally, in this day and age, considered a better approach, right? It's got a number of advantages because it's more powerful, it's more flexible because it can take context into account. It can encode part of speech and other linguistic aspects, right? And it can, with statistical and machine learning approaches to this, right, you can learn complex rules and patterns that you might not be able to specify kind of by hand. But there are disadvantages, right? Of course, we all know about the black box problem. This has come up in this conference several times. And you need large amounts of training data if you're going to train a statistical model. And the third and final kind of con in this pros and cons list is really the issue that we ran into, right? Which is that we have this beautiful kind of statistical model. It's already been trained on a large corpus of English, but it wasn't our English, right? And this is what we're going to get into, right? Because there is no, as a linguist, I sort of have the philosophy that there is really no such thing as English, right? There's no one language, English. There's lots of different Englishes, right? And so here we have a very specialized domain, biomedical literature, right? And right away we noticed it's not stemming all of our words correctly, right? And we were able to, in Semaphore, to actually generate reports that we could identify all the cases where we basically pulled out all the plural nouns where it wasn't producing a stem that was different, and we just listed them out. And we were like, what do these things have in common? Well, they have a few things in common, right? Of course, they're all plural nouns. They are sort of fancy biomedical words, right? They're sort of morphologically complex, lots of graphes and sthesias and bios and elastos, right? They sort of have lots of prefixes and suffixes. And of course, the linguist in me, my linguistic training immediately, I latched on to the fact that these are almost all Greek words in origin, right? So I'm sort of an etymology nerd, so I'm like, oh, it's all Greek. Okay, so it doesn't know how to handle Greek plural nouns. Well, that's not so surprising because in the training data that it gets, it's not going to see probably a ton of these because this is sort of a fancier sector of the English vocabulary. So therefore, you're not going to see this if in a corpus of general English, you're not going to see millions of these examples. So, statistical models, they can only learn from what they see, right? So this was the issue that we came across. And so Jim, I'll hand it back over to Jim to talk about kind of how we work together to come up with a solution for this.
Thanks, John. Yeah, so just to get into that, I want to start with another overview of the components of Semaphore. Semaphore, as John's already indicated, it's an ontology tool. So for managing your knowledge models, whether they're taxonomies, ontologies, whatever, it makes it easy to manage those, easy to build them, easy to socialize them, easy to import them. And of course, in the biomedical space, there are a lot of external vocabularies to take advantage of, and there are, mostly great advantages to that, but some limitations as well. I mean, those ontologies are not maybe designed for your purpose, for those watch portals that John described. They cover every topic. Well, these teams at AbbVie are focused on very specific topics, so that's why they're able to, use Semaphore to leverage those big ontologies, but target them at particular business values. So we have these semantic models, and we put them, we like to say, we put the models to work, and in text analytics. And that involves both, traditional classification. What are your documents about? Creating metadata to go into your content management system or SharePoint, things like that. But also getting more into information extraction. So what is explicitly stated in a document needs to be extracted as metadata, as Jeremy described in a couple of use cases earlier in this room. So I want to focus on the relationship between those two, because that's the key to solving these problems. It's using the NLP stack in conjunction with an ontology that's specialized towards this domain. And lastly, and one of the great differentiator of Semaphore is that we work at enterprise scale. So we're used in very large organizations that process a lot of information. Small organizations too, but we're designed to scale out to accommodate that. So let's look at the pipeline that Semaphore uses to process information. The context of this entire conference is really about this, right? It's taking all your stuff that could be in any form. It could be data, it could be words, it could be documents, and turning it into metadata that you can use to solve problems. Well, how does Semaphore do that? First, we take the corpus. There's two pipelines here. I'm going to show you this one at the bottom because it takes the documents and runs it through our NLP stack. And that includes zoning, identifying where are the words, where are the tokens, where are the punctuation, the paragraphs, where are the entities, the people, places, things, doing just general text mining, make sure you pulling out all the noun phrases, pulling out all the additional information you might be looking for, and importantly, identifying the part of speech of terms. That's a big NLP component here, because once you know the part of speech, then you can stem things accurately. So if you know what the part of speech of back is, it stems differently depending on what the part of speech is. So that gets to the end of that pipeline with just all that markup. And if you were in the session next to us, I think that would be all you'd get, But with which is all about developing training sets to do this type of work. But Semaphore also has the models. And the first thing we do with our models is we provide the tools to say, okay, what purpose is this model for? Do I need all the model? Do I need some of the model? Do I need 3 of the models joined together? All that can be packaged and then published. And as it's published, we identify all the words in the model. We look at multiple words, single words. We generate preclusion indexes, so words that are part of other words don't get tagged twice. We handle a lot of variants just from the model itself. And of course, we leverage everything that's in the model, relationships to other concepts, all the different types of alternate labels that you could have for a concept, any type of evidence that's modeled in the ontology component of Semaphore. And then so that all generates rules. We're a rule-based engine, but we apply those rules to text that has been already analyzed and marked up by the NLP engine. And that's where the secret sauce is combining those two together in very valuable ways. Because ultimately, we're delivering oncology watch portals to our business users that need answers. So I took those two examples that John just went through, and I kind of went to town with them. So if you start with biomarkers, I went to town more with BAC. We'll get to that next one. But biomarkers is a little more straightforward because basically we needed to tell the engine that biomarker and biomarkers was the same word. And that's actually something that's nice about Semaphore because our NLP engine is extensible. So, but the first thing we could say is, well, just add it to your model, John. Just add biomarkers as a synonym. What's the problem? But the problem is, it's not just biomarkers. It's predictive biomarkers. It's genetic biomarkers. It's biomarkers this, and so that it's a word that's used in many different terms across many different models. And secondly, the models are largely publicly sourced. So every time you bring in a new model, you've got to go through every single place that biomarker appears in your model and create the variant. No, that's not practical. You want to deal with the word itself. So that then becomes universal to all your models. So that's a fairly straightforward thing to do with Semaphore. We're just creating a custom biomedical dictionary. And based on the analysis that John did with his models, seeing what words are stemming, which words are not stemming, we created a simple dictionary that says, okay, biomarkers and biomarkers are the same thing, and they're a noun. And that way, now we can use all that information in our rules. We can look for the noun biomarker, or now the rules know how to find any variation on the term biomarkers. If biomarking was a word, we could add that too. So that's the first challenge. The second challenge of BAC, which is a little more fun, because BAC, can mean anything. We had a little brainstorm at Smartlogic, like how many ways can you think of how to use BAC? And like, back me up on this. I've got your back. You owe me back pay. I have a rash on my back. Baby back ribs was a good one. And when you look at this in more detail, the only ones you're looking for are the ones that deal with either back pain or the anatomical thing called the back. So you're really trying to, out of all this noise, you're trying to find what are the ones that are actually medically relevant. And part of speech is part of the answer, because these are all different parts of speech, but it doesn't give you all the answers, because across the phrases that I'm looking for, there are nouns that I got your back. The back of my leg is not your back. So how do you tell the difference between those? Parts of speech is one thing you can use. So what's cool about Semaphore is you can model that and say, look for the part of speech of back as a noun, and that gets you part of the way. So looking at all the terms, some of these sentences and how we're going to pull them apart, first we say, look only for the noun. And that, because it stems it, because as a noun, doesn't come up with backing, it just uses back and backs. And so it finds some of them, it finds 3. It misses this one, and I think this is interesting. It's an NLP engine, natural language. This is not natural language. This is a form. So how do you identify that? So that's where a model comes into play. So we thought, well, how do we? Because we're also finding, with just looking for a noun, we're finding the backs of your legs, the back of your arm, etc. So what do we do to prevent that? Now we could just add, and this is actually my first approach, just to add things like other body parts and look for those body parts near the noun back. So back of the leg, back of the arm, and we thought, well, actually, no, all you need to look for is another part of speech of a certain type near it. So we can actually put that in the model, and if you can see that, we're looking for a noun next to, or in the same phrase as a noun, a preposition, or an adverb, because those are all the possible things that version could be. And that helps eliminate those false hits. And then the form, again, it's not natural language, so part of speech isn't going to help us here, because it's just going to take its default part of speech here, which I think is an adverb or something. But so actually there you just add you use what Semaphore does great, and you add an alternate label that looks for those types of variants. And now you've got a very targeted, correct classification for the concept back in your model. So in Semaphore, that's kind of the abstract view, but in Semaphore, we add the concept, and we can actually add those part of speech tags in the model, which is pretty cool, because that just feeds back into that pipeline. So when you get to the rules can find the parts of speech that have been tagged by the NLP engine. That's how it works. So in conclusion, you need both. You need, to get quality metadata, it's knowledge modeling and the NLP engine. NLP by itself is not going to solve every problem. And modeling isn't necessarily going to solve modeling can be significantly helped by the NLP engine, or else you're spending a lot of time modeling things that can be handled much more efficiently through a trained NLP engine, and especially an NLP engine that can be adapted. So yeah, in terms of, just to highlight that, NLP engines can also be black boxes. You buy them off the shelf, they do what they do, and that's what you get. You want something that's flexible, that you can adapt to your use cases. And bringing those two things close together to make them really efficient. How do you keep these custom dictionaries up to date? What's the best way to manage that? Are the capabilities that we're continuing to develop. Anything to add to that, John?
Yeah, and I would just underscore kind of the awareness issue, right? So it's nice that we have this flexible NLP engine and this flexible framework that we can overcome some of these initial roadblocks, right? But you have to look out for the roadblocks in the first place, right? So just as a user of these tools, my lesson is really, don't just apply an out-of-the-box NLP engine and then say, I'm done, I'm good, right? But actually analyze, look at your results, analyze what's going wrong, and if it's a flexible framework, there will be a way to fix it, right? But just be aware of these domain considerations. Again, there is no one English language, so be aware that if you're in some specialized domain, certain tools may not work out of the box. You need a little bit of that flexibility to make it work.
Thank you.
Thanks.